All right, guys, now we're going to talk about connective tissue. And you're going to see over the next 2 or 3 pages, we're going to talk about the cells of connective tissue, the fibers of connective tissue, and we're going to talk about the specialized connective tissue. And that last one, specialized, is where the test question should come from. Okay, so really hone in on that. But before we get into any of that, I want you to glance at the notes with me. And you're going to see we're going to talk about, second bullet point underneath connective tissue, where it's derived from, okay? And if you kind of have your eyes have a tendency to gloss over when you hit embryology, stay with me for a minute, because you want to think, look at this visual, there's endoderm, ectoderm, and mesoderm, all right? When you get to mesoderm or mesoderm, however you want to say it, think muscle, okay? Any test question about development that has to do with muscle, think mesoderm, okay? If they want to get a little pickier, remember that mesenchyme is a type of mesoderm, and mesenchyme does blood vessels and does bone, okay? So pay attention to that. That has been hit on old tests, so get the big picture down on embryology as we move on to the next concept, okay? All right, guys, let's dive into the heading that says connective tissue proper. I mean, if that doesn't get you fired up, what does? I mean, come on, let's get rocking and rolling here. So my question to you guys, when you think of connective tissue and you compare it to epithelial tissue, do you think that connective tissue has more fibers or less fibers? More fibers, yes. And you want to know that what creates those fibers is going to be fibroblasts, and that's a hot topic in the notes. So go down to cells of connective tissue, look at the first bullet point that says fibroblast. Okay, and what I want you to know is put an arrow to your left and make sure you remember that fibroblasts are inhibited by what? Okay, you're going to want to know that that's going to be steroids. Steroids are going to inhibit fibroblasts. That could be a good stretch question they could ask, okay? But the other thing I want to hit on with you right now is just to talk about what steroids do to the body, okay? We're going to just do a quick timeout. I want you to look at this visual with me, and I want you to picture someone who's been on chronic steroids, okay? Are they going to have weight loss or weight gain? Well, you know they're going to be heavier, weight gain, right? You can think of someone with Cushing's syndrome, right? Remember Cushing's, think of it like a cushion, too much steroids, okay? So picture this like 65-year-old diabetic. That's the classic guy you want to picture who's overweight, okay, who's been on steroids too long. Because you know that steroids increase your blood glucose. That's a key point. You also know that steroids do what to bones? Do they thicken bones or thin bones? Thin bones, yes, that's called osteoporosis. That could be a good test question, and it has been asked on old tests. The other thing I want you to know is that when you're a diabetic, okay, from too much steroids, think too much steroids, you're going to have a decrease in your ability to heal, okay? You can think of the classic diabetic who has like a lesion on their foot, and that's because circulation is going to be less to the foot, right? But also because of fibroblast inhibition, okay? So pay attention to that. Thanks for letting me take a time out there. That's really important, is to think about steroids. You've heard me say several times, steroids, big deal. Okay, you want to pay attention to that. Now, as we get into fibroblasts, I want you to also take a look at this visual of just past test question we've seen on this. Okay, so take a look at that. It's fun to constantly review upon things we've hit earlier, isn't it? It constantly brings it home. The repetition is really critical to doing well on this test. So I'll constantly bring in stuff and repeat stuff. I saw a study recently that said the average adult needs to hear something 28 times before they remember it. None of you are average, I know that. But I think if for some of us it's 5 or 6 times, great. I'll try and keep bringing the repetition, baby. Now look at plasma cells. It says plasma cells are B lymphocytes that produce antibodies. Hammer that in. I'm going to talk about that in a few pages. Just remember, antibodies are produced by plasma cells, okay? Now if you go on to mast cells, which is the next bullet point, read that first sentence with me. Recall that mast cells have granules that contain histamine. Histamine, huge, okay? This is another big comment. If you don't remember anything else about histamine, okay, I want you to think vasodilation. Histamine is a phenomenal vasodilator. And if you know that, it'll help you get some of the test questions right. So take a look at this visual with me. If you know it's a vasodilator, it'll help you remember that histamine causes decreased blood pressure, okay? The other thing it'll help you remember is that it can also cause your blood to pool in your periphery. So that's why these patients have redness, right, in their face and in their hands, etc., is because of that blood pooling in the periphery, okay? You want to know histamine, you want to associate that with type 1 hypersensitivity reactions, and you want to associate it with constriction where in the body? In the lungs, bronchoconstriction, okay? So say this with me now. When you think histamine, think vasodilation, but bronchoconstriction, okay? Make sure you know that. associate histamine with type 1 hypersensitivity reactions. You'll see that in the systemic disease portion of your notes as well, but make sure you got that point down, okay? Now, as we get into the next bullet point, macrophages, you know that macrophages eat other things. They're phagocytic, okay? And we have some examples there. When you see microglial on the exam, think brain. When you see Kupffer cells, definitely think liver. And when you see monocytes, that means they're in the blood. When monocytes leave the blood and they get into connective tissue, what's the name now, guys? Write that in your notes. It says right there it's called a macrophage. So the only difference between a macrophage and a monocyte is location, all right? So make sure you hone in on that. Two other macrophages that they could put on the test are going to be right here, dendritic cells and Langerhans cells, okay? So pay attention to that in case they ask that on the test. You wanna know those are phagocytic, all right? Last but not least is parasites. As soon as you see parasites, I want you to think powerful. Parasites are powerful. They attach to capillaries and keep them from leaking. And if I asked you right now, name a disease that damages parasites. You got something in your mind that comes out? Yes, diabetes, that's the one, okay? Diabetes damages parasites and makes those capillaries less powerful. As we get into the fibers of connective tissue, collagen is the big one. Look in the notes with me. It says the predominant fiber in connective tissue and the most predominant protein in the body. That's been big. Test question, right here on the visual. What's the most abundant protein in the body? Right here, it's going to be collagen. You're going to see this in biochem. Make sure you know that collagen is always going to be glycine, look at the visual, plus an X and a Y. And almost always that X is going to be proline. Almost always the Y is going to be lysine. So say it with me now, all right? Glycine, proline, lysine. Glycine, proline, lysine. I won't make you say it again. It's almost hard to say fast, isn't it? Make sure you pay attention to that. It's big. You're going to see in biochem, the way that we produce healthy collagen is to have hydroxylation of the proline and lysine residues, and you know that vitamin C does that, okay? You all know that if you have a lack of vitamin C, you get what disease? Scurvy. Every one of you knows that. But the big thing that they get asked on the test is to know what does vitamin C do, and that's what it does, okay? So hone in on that. All right, guys, let's talk about GAGs for a second. And this is exciting because as soon as we get done with this, we get to get into specialized connective tissue, which I told you is where all the great test questions come from. Okay, so let's look at GAGs. If you look there on the first bullet point, it contains a core of disaccharide repeating units. Circle those three words, okay? That's big. And if you go to type of GAGs, hyaluronic acid is the one that typically gets hit on old test. Pay attention to that because it's really unique. If you read there, it says it's unique because it does not contain any sulfate and it's not bound to a protein. So say that to yourself, no sulfate, no protein. Now, if you scroll down in your notes, you'll see a dash there that says note, proteoglycans do contain what? A sulfated GAG and they contain a protein. So hone in on those differences because the take-home message is that hyaluronic acid is a GAG, but it's not a proteoglycan, okay? So make sure you pay attention to that. All right, guys, let's get into specialized connective tissue. This is big, and I want you to get every single one of these questions right. So I'm going to kind of coach you through this very carefully and make sure that we really get the key points, all right? The first thing I want to point out is if you look underneath blood, about 55% is plasma, 45% is red blood cells, okay? Now, if you think of it that way, the rest, which is like less than 1%, is going to be white blood cells and platelets. So if we look at plasma, which right off the bat, I think we use that term all the time in school, plasma, but what is it? It's a non-cellular portion of blood. So they could ask you what's in the plasma, and as you look in your notes here, it says 80% is water. That doesn't make for a very great board question. The protein is what makes for a good board question, and I just like to ask you now, can you think of what protein is in the plasma? Well, there's three main ones I want you to pay attention to. Now look at it with me. The first dash says complement pathway. So complement proteins are one of the three proteins you want to know. And actually, if you look right above that, in that paragraph above complement pathway, you'll see albumin. That's the other big one, okay? And last but not least, underneath gamma, you'll see plasma cells, okay? So look at this visual for a second. When you think of plasma, you want to think of it again as mainly water, but you want to think of it as these three proteins: albumin, complement proteins, and you want to think about antibodies, okay? Those three are the ones you want to hone in on. Now let me ask you a question. Who makes antibodies again? Plasma cells, yes. Another thing I want to ask you is, later on we're going to talk about complement pathway, and you need to kind of associate in your mind right now, complement pathway is not hard. All it is complement proteins, which are going to be in the plasma. And if they ask you on boards, who makes complement proteins? Then you want to say liver. If they ask you on boards, who makes albumin? You want to say liver, okay? Those are kind of key things you want to know about the plasma. Last but not least, if they ask you a question about albumin, the top question that keeps showing up is right here. Look at the visual right here. They want you to know that. Okay, when you think of poor nutrition, I want your brain to go to less albumin in the blood. All right, that's a key thing to know. All right, guys, now we get to talk about the cellular portion of blood. So as we look at this visual here, again, when you think of blood, non-cellular portion, that's the plasma. Cellular portion is going to be red blood cells, white blood cells, and platelets. That's the big picture. Now let's dive into the notes. Look at red blood cells. It says 45% of your total blood transports oxygen, removes carbon dioxide. Don't forget that. Now, if you look at the first bullet point, lifespan 120 days, that's been asked. The next bullet point has also been asked. It's saying, where is it recycled? In the spleen. So I want you to think of it this way. Write this phrase in your margin. Say that the spleen splinters red blood cells. The spleen splinters red blood cells. That's an important thing to pay attention to. Next bullet point, a nuclear, we talked about that, biconcave disc structure. Do you remember that from before? Good. And next bullet point, it's the most abundant cell in the blood, and it's not even close. We just said 45% of total blood, almost all of that, the cellular portion, is red blood cells. So the other thing I want to mention here, the last bullet point, talks about hemoglobin consists of iron, and it says that iron binds oxygen. Remember that binding, if you want to make a note there, is going to be reversible binding, as opposed to when iron binds carbon monoxide, that is irreversible binding. That's why carbon monoxide is so dangerous, all right? So now we get into white blood cells. You guys remember white blood cells only 1%, but lots of test questions come from this 1%. When we organize white blood cells, first thing you want to know in that first sentence, it says it's found in the bone marrow is where these are produced, right? Now, if you get into white blood cells, there's granulocytes and agranulocytes, all right? So let's take a look at this visual for just a second. You guys can see that granulocytes consist of BEN, B-E-N. Say it to yourself. Granulocytes, BEN. Basophils, eosinophils, neutrophils. Which one of those three, by the way, is going to be most common? That's going to be neutrophils. It's not even close. Basophils are going to be least common. There's a mnemonic that people like. It's in the book here. Remember, it says, never let monkeys eat bananas. That's like the silliest and stupidest mnemonic ever, but it helps. I'll just tell you a really quick story about this. When I was at Indiana, I remember finding a basophil in a lab, and I wasn't very good at histology, like finding the cells. And I remember our British professor came over, and I remember her saying, like, Kyle found a basophil, you know, and she made a big deal about this. And she said, and it's really large. That's what she said. And as people were coming over, she mumbled under her breath, not that size really matters anyway. It was really awkward and really funny, and people really enjoyed it. So it always helped me remember that basophils are very, very rare. They're hard to find on a microscope. As we get into this, when you think of granulocytes again, basophils are not, by the way, this is a key test question that has been hit. Take a look at this visual right here. Basophils are not phagocytic, okay? Whereas eosinophils and neutrophils are, all right? Basophils, one of the things they've been wanting you to know in terms of old test questions is that they increase vascular permeability. Okay, they're not phagocytic, but they increase the ability of other things to come to the site to eat it. Okay, so eosinophils, neutrophils are phagocytic, basophils are not. Now I want to show you one other visual to kind of summarize the red blood cells, white blood cells, platelets, some of the things we've seen on old tests. Take a look at this visual just to make sure we've got it hammered down. All right, guys, now we're going to talk about platelets. If I'd asked you guys, first thing you think of with platelets, I'm sure of, is platelets are going to help with blood clotting. I'm sure that's pretty natural to you. But the test question is more likely going to be, how do they do that very specifically? They produce something. They produce, first line right there, let's go to your notes. Platelets produce the enzyme thromboplastin. Okay, and you guys know that creates a cascade of events. Eventually, fibrin forms the clot. Okay, so it starts the cascade. That's how you want to think of what platelets do. Okay? All right, guys, now we're going to talk about bone. And as we get into this, I'm going to just tell you something I mentioned earlier. When you think of bone, what does it do? It's going to produce something. Do you remember what it is? B and T cells. Good. We might remember that T cells are produced in the bone marrow, right? But they mature where? In the thymus. Yes, okay? So we're going to get into that in a second. The other thing I want to kind of remind you is that bone is going to store something. And let's look at that now in your notes. First bullet point. Bone is going to store calcium. And if they ask you on the test, put an arrow right above calcium and ask yourself this question: what cell type breaks down bone? Do you remember that? It's going to be osteoclast. Yes, that's a key thing you want to remember. We'll talk more about that in a second. So let's get down to osteoblasts and osteoclasts. You might remember osteoblasts, they build bone. Okay? Whereas osteoclasts, they break down bone. So when you look at osteoclasts in your notes, it says large phagocytic cells responsible for breaking down and remodeling the matrix. So let's look at how they could get trickier on a test in terms of a test question. So as you see in your notes here, it says calcium homeostasis. You want to think calcitonin, again, the IN at the end of the word inhibits osteoclast, whereas parathyroid hormone is going to stimulate osteoclast, all right? Just remember those two are enemies. I just want to review it one more time right there in your notes, all right? So now let's go to cartilage. Cartilage is very unique because it's very well hydrated and it's avascular, okay? And so as you see in your notes, first bullet point, avascular, well hydrated, type 2 collagen that has been asked on old tests. Cartilage is type 2 collagen, and chondroitin sulfate, highlight that as well. I know I'm just kind of mentioning the key points in the notes, but this has also been hit a few times. Take a look at this visual on hyaline cartilage. Okay, this is important and I would pay attention to this. Little picky, cartilage hasn't been hit that much on old tests, but this has. All right, guys, now we're going to get into muscle. The big thing I want you to remember about this is it's of mesoderm origin. Remember, there's ectoderm, endoderm, mesoderm. This is going to come from mesoderm, right? And as we get into the types of muscle, you can see there in your notes, there's skeletal, cardiac, smooth. I want to look at skeletal muscle with you for a second, and I want you to look at this visual, kind of a funny little visual I drew to kind of help you remember this. So the key things, again, is going to be peripheral nuclei, multiple nuclei. Whereas cardiac, as you look at this visual, a little heart here, you're going to have 2 nuclei typically, and both of them are going to be in the center of the cell. Smooth muscle, I would just skim there, pause and skim, and let's get ready for the next section, which is going to be nervous tissue. All right, guys, as we get into nervous tissue, I want to talk about neurons, and I want to point your eyes in the notes to axon hillock, okay? Because this is the portion where action potentials are generated. You're going to see in your notes there's no Nissl bodies here, okay? So when you think about that, make sure you remember axon hillock, circle that A and think action potential. And as you go down to propagation of nerve impulse, you want to pay attention to that first bullet point. Look in the notes with me. It says propagation is typically unidirectional from dendrite to cell body to axon. Dendrite, cell body, axon, right? I know that's pretty basic stuff, but you might remember orthograde in the next dash is saying propagation from cell body to axon. That's what you'd expect. So make a note in your margin, write the phrase ortho cell, okay? Because if they ask you on boards, they're going to want you to know where does the impulse start, and it starts in the cell body to the axon, right? As opposed to retrograde starts on the axon to cell body. Okay, so you might even write the phrase retroaxon, whereas orthograde, again, ortho cell. It's all about where it starts. Pay attention to that, okay? As we get into myelin, there's some really good questions here, okay? So hone in on this. You can see the first bullet point, it speeds the contraction. You know in the second bullet point, it does that through the nodes of Ranvier. And that skipping along those nodes is called, in the third bullet point, it's going to be called saltatory conduction. All right, I know this, you've had these terms for a long time. Where it gets picky in terms of a test question is to know the differences between the CNS and the PNS. Right here in your notes, it says CNS has oligodendrocytes. Circle those 3 letters in the middle of oligodendrocytes, G-O-D, God. Think God as being central, okay? And think of God as caring about multiple people. Just hang with me for a second, because when you look at the notes here, if you think God, central, CNS, and if you read the notes there, it says oligodendrocytes wrap around multiple axons, okay? That's the test question. They want you to know that oligodendrocytes don't just focus on one axon, they take care of multiple axons, okay? By the way, do you remember the other cell type in the CNS besides oligodendrocytes? The other big one is going to be astrocytes, which you'll see on the next page. So you need to put astrocytes, oligodendrocytes in the same spot of your mind, which is in the CNS. Now, if you go to PNS, it says there's Schwann cells. It says they produce myelin for only one axon, okay? So Schwann cells, when you think about that, they only have one axon, but think of it this way, Schwann cells care deeply about that one axon. Because do you remember what Schwann cells have that's like totally unique and makes for a great board question? They have a basement membrane, right, that's called the neurolemma. Yes. So let's look at the next page, and I want to point your eyes to that. So on this next page, you can see Schwann cells there, and it says encased in a basement membrane called the neurolemma, right? Why does that make for a good test question? Because look at the next bullet point. That allows nerve regeneration. So if they ask you on boards, nerve regeneration can happen in the PNS, but not in the CNS. And that's all because of this neurolemma of Schwann cells, all right? Pay attention to that. It's a really good question. Remember, Schwann cells, they can only take care of one axon, but they do it with much care. Think of it that way, because they can regenerate, all right? That's a key thing to know. All right, guys, we're going to get into skin now, and I want you to just kind of take a mental break. Don't worry about looking at the notes for a minute. Just look at this visual. Let me guide you through it. After I'm done talking you through this visual, just push pause and make sure that you got the key points down. All right, so let's look at this together. You guys know that the layers of the epidermis, you've heard these, there's 5 main layers, and the mnemonic that we use is, can Lucy give some blood? Can Lucy give some blood? If you like that, great. If you don't, you can make up your own, obviously. But the thing I want you to pay attention to is, if they ask you a question like, where out of these layers would you have zonula occludens? Do you remember that's tight junctions, right? Yes. You remember desmosomes? What are they? Spot weld, right? What's the other name for desmosomes? You guys remember? Macular adherens. Yes, macular adherens, MAD, M-A-D. Do you remember that from earlier? Good. All right, we're getting this. So that's going to be on the front layer, the corneum layer, right? When you say Lucy, can Lucy, I want you to think of Lucy as like a thick, like a really strong girl, because lucidum is only in thick skin, all right? That's a key point that they keep stressing on old tests, okay? The other thing I want to point out is, when you see granulosum, you probably think granules, yes. On the old test, they've wanted you to know that that's keratohyalin granules, okay? That's the type of granules. And even though they're found in the granulosum layer, they're actually produced in the layer below that, which is the stratum spinosum. That's been another picky question. So think of those granules as being produced in the spinosum and then moving their way up into the granular layer, okay? Now, next thing I want to hit is, obviously, if they say something about squamous cell carcinoma, you want to think in the stratum spinosum. That's a no-brainer. If they say basal cell carcinoma, you're going to say stratum basal. No question. That's easy. The thing I want you to pay attention to, though, is that there's also melanocytes in the stratum basal, right? So if they ask about a malignant melanoma, you want to pay attention to the fact that that is going to be starting in the stratum basal. That would be a tricky question that you'll dominate. Now, another stretch concept I want to ask you is, if they asked you what light is most dangerous, UVA, UVB, or UVC, all of you are going to think UVC. Yes, it has short wavelengths, so very dangerous. So it would be natural to think that UVC would be the culprit of a basal cell or squamous cell carcinoma, but that's not the case, because the atmosphere blocks UVC light. Okay, so if they ask you on the test, remember it's UVB that's going to be responsible for causing squamous cell and basal cell carcinomas. That's going to be the most common form. Another thing I want to point out for you guys is to get straight in your mind the difference between a melanosome, melanocyte, and melanin. So take a look at this visual for a second. You can see that melanocyte is the cell. It's a very common cell. Like 1 out of every 10 cells in our body is a melanocyte. Okay, and when they say anything about a cancer on boards, like a cancer of of a skin cell like this, you want to think it's going to be a cancer of melanocytes. Don't confuse melanin and melanosomes. The cancers are going to be melanocytes, okay? Now, when you think about the melanosome, that's the organelle, and that melanosome is going to produce melanin, which is the pigment within it, okay? So this visual hopefully kind of helps get that straight in your mind. But again, the reason I'm putting this up here is because the test questions are typically going to be going after melanocytes, all right? Now, as we get into the next thing, everybody, we're going to talk about the dermis. And I want to point your eyes to this quickly. There's not a lot here I want to pay attention to. I want you to know there's, second bullet point, open-ended nerve endings here. So if they ask you about nociceptors, they're located here in the dermis. I also want you to know that the dermis is highly vascularized. So if you go down to the bullet point later on in your notes there, you'll see cutaneous plexus, subpapillary plexus. Okay, that's the key thing, is to remember, again, blood vessels are happening here in the dermis and supplying the epidermis. All right, that's the key thing to pay attention to. Okay, guys, last but not least, we're going to look at the hypodermis. All right, as you look at this in your notes, first bullet point, adipose tissue, all the way to the right there, circle the word insulator. Okay, that's a key thing to know. The other thing I would pay attention to in this is the sebaceous glands. That's where they're located. That's been something that's been emphasized, so just hone in on that and know that sebaceous glands and sweat glands are located in the hypodermis, all right? Okay, guys, as we get into cardiovascular system, this has not been a really hot topic in terms of histology, so I would pretty much pause and skim this. There's a couple things I want to point out to you. If you look underneath epicardium, the unique characteristics of the pulmonary artery and the pulmonary vein, so pay attention to that, and that's one thing I would hone in on. The other thing is when you get to the comparison of arteries versus veins, okay? So when you get to that comparison, there's a few points there that I would pay attention to. Let's go there in your notes together, guys, where it says comparison of arteries versus veins. It says the tunica media is the most dominant layer in arteries, whereas the adventitia is the most prominent in veins. And if you look at your notes in there, you're going to see something called the vasovasorum. That's part of the tunica adventitia. And you guys might remember that the vasovasorum supplies parasites. As soon as I say that, you're thinking diabetes, right? So that's what they could go after. When you think adventitia, think veins and vasovasorum. When you think media, think thickest in the arteries. Okay, guys, now we're going to get into lymphatic system. We're going to talk about lymph nodes and how lymph is formed. If they ask you underneath formation of lymph, how does the lymph form? First bullet point there, it says as blood passes through capillaries, hydrostatic pressure within the blood pushes the fluid out of the plasma and into these lymph vessels. So what's the key there, guys? Hydrostatic pressure. Right above hydrostatic pressure, if you're thinking, what is that? That's heart pressure. Think of it blood pressure. So whenever I see hydrostatic, I always think heart. Okay, so pay attention to that. That's where lymph starts. Now, as you get into lymphatic vessels, pay attention to the box there, okay? Because that's a really, really key thing. You want to know that the thoracic duct is returning most of the lymph back to the bloodstream on the left side, okay? That's the key thing in terms of how does the lymph get back into the blood vessels, is through the thoracic duct on the left side. That's key. That's been asked literally almost every single time. That is a really, really hot item and kind of a random one for them to go after, but pay attention to that. The next thing, everybody, on lymph nodes, you know that most of the lymph nodes are underneath your armpits and in flexor joints, 500 to 600. As we look at functions of lymph nodes, look at the first bullet point where it says they produce antibodies. You probably remember that, but make a note next to that. If they ask you on the test, remember that most antibodies are produced by plasma cells, right? So make a note of that. Remember, plasma cells are just mature B lymphocytes. You can go ahead and pause and skim on the associated lymph structures. Not a lot there that's been very important on old tests. All right, guys, now we're going to talk about the lymphoid organs. You can see there in the book that they all contain germinal centers, and all of them produce lymphocytes, right? You can see there's the tonsils, the spleen, and the thymus. We're not going to worry about the tonsils. I would just cross that out. And let's look here at the thymus. First thing I want to know about the thymus is T cells maturation. That's where it occurs. By the way, on thymus and spleen, definitely know the big picture here is location and function. You want to know where they're located and what is their function. So as you look at thymus here, located first bullet point in the mediastinum, right? The other thing you want to know is its function, thymic education. That means maturation of T cells. So when you think about T cells, you're going to see this in immunology. T cells are made in the bone marrow, right? They go to the thymus to mature, and the way to think of that in kind of common everyday language is that these T cells get like a birthmark that makes them very specific. It's like this unique little birthmark, and their whole life they spend looking for an antigen that has the exact same birthmark. So most T cells spend their whole life looking for an antigen they'll never find. Isn't that sad? So when you think about T cell maturation, that's what that means, okay? So the other thing about function, though, of T cells is where it says hematopoiesis in fetus, okay? So it makes the blood in fetus. Later this happens in the bone marrow, as you might know, but that would be another function of T cells that has been hit on old tests, hematopoiesis, and then think thymic education or maturation of T cells. Okay guys, you know we keep mentioning with these lymphoid organs that we need to know function, right? And we also need to know location. So when it comes to spleen, look at what it says, first bullet point, located behind the stomach, right? In the upper left quadrant of the abdomen. Good, know that. Now, you guys remember what is the function of the spleen? It splinters, yes, red blood cells. That's a major function of it. And it's going to take that information and send it over to the liver, you might remember, to make bile, okay? So as we look here at the second bullet point, I would know the red pulp and the white pulp. The red pulp, as it says here, is red blood cells, right? That's where you're gonna filter out the red blood cells. The white pulp, think of it as where you have a war on antigens, okay? It says right here, the white pulp contains T and B cells, and this is where you're going to fight antigens, okay? So pay attention to that. Okay guys, now we're going to talk about the respiratory system, and there's an upper and lower respiratory system. The upper has not had many questions at all, so we want to focus our attention on the lower pretty much exclusively. You guys know that the lower respiratory system, as we look down here in our notes, is the trachea down to the lungs. One of the big test questions wants you to understand that the trachea initially starts the whole process, and then it divides into bronchi, and then bronchi divide into bronchioles. So look at this visual with me for a second, because one of the test questions that keeps coming up is they want you to know in between the trachea, right, and the bronchi, you're going to have C-shaped hyaline cartilage, okay? Then once you get to the bronchi, okay, and go down to the bronchioles, you're going to have a complete ring, not a C-shaped, a complete ring of hyaline cartilage. And then once you get from bronchioles down, you have no hyaline cartilage, okay? So pay attention to that. Make sure you have that down in case they ask a question on that. So the next thing we want to focus on in your notes is where you get to alveoli, okay? This is where most of the test questions have come from, is wanting you to understand, first bullet point, that it's lined with type 1 pneumocytes, which do gas exchange. That's the big thing. Type 1 does gas exchange, type 2 does not. But look at the second bullet point. It says type 1 pneumocytes, even though they do gas exchange, they cannot regenerate. It says type 2, the next bullet point, will divide and replace type 1. Next bullet point, type 2 produces surfactant, okay? So that's kind of the key points you want to understand, kind of the key takeaways. But look at this visual, because I want to show you another test question that's commonly been represented. Again, remember the big point, type 1 pneumocytes, right, are going to do gas exchange, type 2 are not. Type 1 cannot regenerate, type 2 do not do gas exchange, right? Those key points. But look at this visual here to see another way this has been asked, all about having to do with cilia. Pay attention to that on the test as well.